This is Geometry Semester 2. It is a unit number 10, Pythagorean Review. It's lesson 3, Solving for Legs and Hypotenuse Practice. It's on creatormath.com. You might have to type in creatormath.weebly.com, and it's under the Geometry tab. Copy the following problems 1 through 16 into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Make sure you are not doing more than 16 problems. There might be more on the page, but that's all you're required to do for the assignment. So just to show you creatormath.weebly.com, the home page looks like this. Make sure you're under the Geometry tab. Pass by the vocabulary and find this unit. This is the table of contents, right? So I'm going a little fast here. Semester 2, table of contents. This should be on pages 2 through 6 of your composition book. Should have been copied there a long time ago by now, but go ahead and put it there if it's not. Come down and find this unit on Pythagorean Review. There it was, Pythagorean Review. There's 1, 2, 3, 4, 5 lessons here. What is this one? Number 3. This is lesson number 3 right here. So it goes on these pages of your comp book. There'll be notes right here for you to copy on there. There'll be problem sets like I'm doing, and a video of this right here. That'll be linked up by the time you see this. Don't follow the page numbers from this video. Go to the actual table of contents to find them. So let's see what we got here. How many legs? And this is review for us for Pythagorean. So presumably I don't have to spend too much time explaining. I'll go pretty fast, but hopefully it's a good review. How many legs does a right triangle have? Well, let's draw a right triangle. Here's the 90-degree angle. That makes this the hypotenuse, right? Hypotenuse, or hypotenuse. And that makes this a leg and this a leg. So we like to say a right triangle, or any triangle, has 2 legs like a human. How many hypotenuses does it have? Well, let's stay on the same diagram. There's 1. You got 1 hypotenuse and 2 legs. So this is a leg, this is a leg. 3 sides, that's all you got. So you got 1 hypotenuse. The 2 legs of the right triangle are attached to the right angle. Notice here's a leg touching on, adjacent to, touching the right angle, right? Attached to the right angle. That's what that means. It's easy to find if you give anybody a right triangle, put it in any orientation. The 2 sides touching the 90 degree are the legs, and the one across from it, not touching it, is the hypotenuse. And on that note, can I get all this in the picture at the same time? The hypotenuse is across from the right triangle. So see across from, otherwise known as opposite that right angle. Which of the following is the Pythagorean theorem? All of these. Let's see. Hypotenuse squared equals leg squared. Here's the way students usually learn it. They learn a squared plus b squared equals c squared. Fair enough, but that can be reversed. I like students to say c squared equals a squared plus b squared. Why? I want them to focus on that c term. The c is the most important part because that's got to be the hypotenuse. The other 2 legs can be a or b. Students always struggle to put in the hypotenuse first, so I have them reverse it and say c squared equals a squared plus b squared. I like this one here. I don't like a, b, and c at all. Why use a, b, and c? It's the hypotenuse squared equals leg squared plus leg squared. That's a better representation to me, and it's way better if you're going to learn how to use this, use the fantastic Pythagorean theorem. Leg squared, hypotenuse squared equals leg squared plus leg squared is a better representation. So set up the Pythagorean theorem to solve the following. We don't have to solve it on this one, we just have to set it up. So let's use hyp squared equals leg squared plus leg squared. Where's the hyp? Longest side, not touching the 90. 16 squared equals, and then pick any 2 legs, you can put them in either place. X squared is 1, and the other's 12.8. So 16 squared equals x squared plus 12.8 squared. Set it up. Height squared equals leg squared plus leg squared. This is the height right here because it's across from the 90, not touching it. So x squared in this case. And notice how we put the x in for the leg. It wasn't over here, right? Now we got to get the right. That hypotenuse is essential to line up first. So in this case, with the unknown is the hypotenuse, x squared, and the other is 11.6. Doesn't matter in which place you put it. And 5.3. And might help to put parentheses just to make us see that those take this whole thing and square it, right? So x squared equals 11.6 squared plus 5.3 squared. All right, another setup problem. So height squared equals leg squared plus leg squared. This is the hypotenuse because it's not touching the 90, so that's going to be x. We don't care which side goes in for each, it'll work out the same way. 4.3 squared and 9.6 squared. So that's set up and ready to start solving. So x squared equals 9.6 squared plus 4.3 squared. Check. And by the way, we don't care which leg comes first. See how the 4.3 is second here and the 9.6 is first here? That doesn't matter. By the time you add them, you're going to get the same result, according to our properties of math. Set up the Pythagorean theorem. All right, this is a leg. How do I know? It's attached to the 90. So I've got height squared equals leg squared plus leg squared. Height in this case is not touching the 90, so it's got to be the 8.4. Equals leg squared x in this case plus 8.2 squared. And I might use some parentheses just to make it look better. 8.4 squared equals x squared plus 8.2 squared. Set up again. So let's see. Height squared equals leg squared plus leg squared. Height is not touching the 90. It's across from. So 11.3 squared equals a leg. And I can reverse these. I can say 7.5 squared plus x squared will not matter. We will get the same result for x as long as we do the algebra right. All right, they've asked me a bunch of setup here. How many more setup do I have? Oh, a bunch. Oh, now they want me to go ahead and solve this. So now they've given me one that we already set up. We already set this up on the prior problems. So let's write it out. We have 16 squared equals x squared plus 12.8 squared. That's one we already did. Look back at the prior problems. We have to solve for x. How do you do that? Well, we have to use algebraic solving methods. What you do to one side, you do to the other. We have to isolate the x. All those things your teacher's probably saying to you every day. Subtract 12.8 squared from both sides. What I do to one side, I must do to the other. Keep this center line right down the equals. Get rid of this. We're left with an equals still on the center line, and x squared is left here on the right. And now we have a 16 squared minus a 12.8 squared. Now, to get rid of the square on this, we take the square root of this one, and what we do there, we do here. So we come up with a final answer. I'm going to flip it. X comes here, and we get square root of 16 squared minus 12.8 squared. X equals, this is a square root symbol. Sorry, it's hard to see. The computer doesn't put it over like that, but that's an acceptable square root symbol. 16 squared minus 12.8 squared. It's important the minus is there. That comes from the fact that we subtracted from both sides there. All right, here's another from the prior page. X squared equals 11.6 squared. That's 5.3 squared. All we have to do is take square root of this side and the square root of this side. That's going to get rid of it here. A square root is the reverse of a square, so we're left with x equals this. Square root of 11.6 squared plus 5.3 squared. And I'm sorry this is so hard to see, but that's that little square root symbol there. Right? That's how the computer puts it in. 11.6 squared, 5.3 squared. X equals. Right? This whole thing. And we're not even typing it into the calculator yet, right? We're just rearranging it for solution. All right, let's do two more. Given this one here, x squared equals 9.6 squared plus 4.3 squared. All we do is take the square root of both sides, and x equals the square root of 9.6 squared plus 4.3 squared. And square root of 9.6 squared plus 4.3 squared. If we have 8.4 squared equals x squared plus 8.2 squared, we're going to subtract the 8.2 squared from both sides. Gone from the right side. Remember the center line, that is your equals. The x squared is on the right still. This becomes 8.4 squared minus 8.2 squared. We're going to take the square root of this side to get back to just x, right? And that means you have what you do to one side, you must do to the other. So you're going to have square root of 8.4 squared minus 8.2 squared. And sure enough, x equals square root of 8.4 squared minus 8.2 squared. Okay. All right, now they actually want us to solve. Solve to the nearest tenth. So, we're starting from the beginning here. Hype squared equals leg squared plus leg squared. Let's get a little bit more runway here. All right, hypotenuse is 16. Why? It's not touching the 90. 16 squared equals leg squared, 12.8 squared, plus x squared. Let's subtract the 12.8 squared from both sides. And x squared is now equal to 16 squared is here minus the 12.8 squared. And I flip sides all at the same time. Let's take square root of one side and take square root of the other. That reverses this. X is going to be approximately equal to let's get our calculator open. Don't forget to turn it sideways. Can I see all this in here? Almost. Clear this out. So what do we have? We have a square root symbol. Put that in first. 16 squared, there we go, minus 12.8 squared. And I get a little paranoid. I don't have to do it, you guys, but I kind of like to put a parentheses around the 12.8. I just want the calculator to make sure and square the entire thing. And it does. It knows what I'm doing. It's the, programmers are smart enough to have programmed it that way. But I just like seeing it that way so my brain knows it's squaring that whole thing. I start to get paranoid it's only going to square the 8 and not the 12. It does. Anyway, it's 9.6. So we have 9.6. It's not approximately equal. It is equal to 9.6. And circling that there. How many more did they give us? Just one. So they had us set them up. They had us find the legs and the hypotenuse, set them up, and then solve, set up to solve, and then solve. So here we go again. This is hype squared equals leg squared plus leg squared. We've got a hypotenuse here, unknown. It's not touching the 90. That's how I know it's the hypotenuse. This is x squared. The two legs do touch the 90, so 11.6 squared plus 5.3 squared. All I have to do is take the square root of both sides. I don't even have to rearrange it because they gave me both legs. And I get x equals, let's clear out. It's just probably easier to start over. 11.6 squared, and I will force myself not to put a parentheses around it. 5.3 squared, just to prove it works. And this one I am going to say approximately equal to because of all the decimals I'm truncating. Truncating means to cut off. And they said to the nearest tenth, so that would be 7. So because it's 5 to the right, that's going to go to 8. So I'm going to have 12.8. And there we go. I got that, 12.8. All right, so make sure you're doing the correct assignment. You've got Geometry Semester 2. This is the 10th unit called Pythagorean Review. We already did Pythagorean. This is a review unit. And it's the third lesson in the review unit called Solving for Legs and Hypotenuse Practice. It's on creatormath.com or creatormath.weebly.com under the Geometry tab. I hope this helps.